So today, lesson 8a, graphing and writing equations of all lines. And in some respects, we're just sort of putting together everything that we've been doing in this unit, including working backwards and finding the linear equation, giving a graph, and verbally using correct vocab when discussing a particular linear equation that you're working on. So, a quick review of all the things that we've been working on. We've talked about how to find the slope from a line, thinking of it in terms of the vertical length or vertical change or the rise over the horizontal length or the horizontal change or the run. And today, every single problem, I'm just going to refer to it as rise over run, okay? Including lines with negative slope, which we introduced in the last lesson. We also had a brief discussion, and we'll go into that in more detail, on vertical lines that have a slope of 0, what their equations look like, which they all happen to look like x equals a number, or horizontal lines that have a slope of 0. Those all have an equation of y equals some number. And we sort of put all the different slopes together. Talked about uphill versus downhill versus horizontal versus vertical and their corresponding slope. We also talked about how to use the slope formula to find the slope. And we can go in either direction as long as we stay consistent on that. Okay? Including slopes that are 0 or undefined. And we certainly don't want to get those two ideas mixed up. Okay? Including the graphs. We've taken a look at linear equations and referred to the y-intercept as the initial value and all the different ways that we could see that, and the slope and the rate of change. And we're not filling in anything yet. I'm just sort of quickly reviewing everything that we've talked about. Today we're going to add to this graphing lines with 0 slope and undefined slope. Okay? All right, so now we are at number 1. And we're asked to graph the line x equals 6. Well, if we have an equation of x equals 6, that means in a table, all the x values are always 6. And this is where you start filling in your table. Because that's what it tells us that x is. X is always 6. And y can be anything that we want it to be. So I'm not going to get overly complicated. I'm just going to say y is 0, then it's 1, then it's 2. Now, if we plot all three of those ordered pairs, 6, 0, 6, 1, 6, 2, and then draw a line through them, we can see that we have a vertical line. By the way, from last week, what is the slope of that line? Undefined. One person said 0. It's not 0. It is undefined. All vertical lines have an undefined slope. And so we're sort of putting together this idea that if we have an equation that is just x equals some value, some number, the slope is always 0, and the graph of that is always a vertical line, just going through whatever that value happens to be. Okay? So, all vertical lines, fill in the blank areas, please, have an equation that results in x equals some number. And then it should make sense that if we have an equation that's just y equals some number, by the way, I just said that, but m is equal to undefined. In other words, the slope is undefined for all vertical lines. Make sure you fill in all the blank areas when we get finished here. So if we have y equals -5, that means y in a table, y will always be -5. And then x could be anything that we want it to be. And I'll just, once again, keep it nice and easy. 0, 1, and 2. And if we plot those three ordered pairs and draw a line through, we have a horizontal line. And remember, all horizontal lines have an equation that results in y equals some number, and the slope is 0 for all horizontal lines. So, all equations with only one variable will have graphs that are either a vertical or horizontal line. And I'm going to stop right there to let everybody get caught up with all the blank areas there. All right, so number 3. This will be the first time that we've actually had to graph a line with a negative slope. I know the slope is negative because of the negative 1/2. So the initial value, like with positive slope graphs, the initial value is the same. It's negative 1. All right, returning to this problem. We know the initial value is negative 1, which also means the b value of the y-intercept is negative 1. And as an ordered pair, the y-intercept is 0, negative 1. And that means we would start our graph. That's why it's titled or called the initial value. That's where we start at 0, negative 1. Now, we know that the rate of change is negative 1/2, which means the slope is negative 1/2, and m is also negative 1/2. Okay? Now, before we go from there, we need to kind of remember from 7th grade that negative 1/2, and you don't have to write this part down, but just look up here. Negative 1/2, which is also the same thing as negative 1 over positive 2, or that's also the same thing as positive 1 over negative 2. And remember, when we're thinking about slope, it's always rise over run. So you can either rise negative 1, which is basically what I did right there. Remember from last week, a rise of a positive number means you're going in the upward direction. A rise of a negative number means you're going in the downward direction, because rise is always either up or down. And then a run of a positive number is always to the right. A run of a negative number is always to the left. So I had a rise of negative 1 and a run of a positive 2. Now, you could have also instead, if you wanted to, had a rise of a positive 1 and a run of a negative 2. But look, you're still going to end up lining up everything perfectly because both of those points are on the same line. But I want to bring up something to you, and that is this. Graphing a linear equation using the slope and the y-intercept or the rate of change in the initial value should take like 5 seconds. Because it should work like this. You should plot your y-intercept, use your slope to find one more ordered pair, either one of those, and then draw your line through. That's how fast graphing should happen. Okay? Now, the other thing is this. You should have known, since the slope was negative, that that line is going downhill from left to right. That's another quick check. And then the only other real common mistake is rising to and running negative 1. In other words, doing things backwards. It's always rise over run. Numerator's rise, denominator is run. Okay? So, let's go ahead and turn the page. Let's see how we do here. I'd like you to go ahead and do number 4, 5, and 6. Number 4 is one of these equations with just one variable. So we should automatically know it's either going to be a horizontal line or a vertical line. If you don't remember, maybe set up a quick table. Remember, y is negative 4. How do I know that? Because that's what it's telling us. And I really only need 2 points. X can be anything that you want it to be. So 0, negative 4, 1, negative 4. Clearly, this is a horizontal line. By the way, what's the slope of that line? What is it? 0. It's 0. Thank you. All horizontal lines have a slope of 0. All right. Or something like that. Number 5. I know that b is negative 5. So right there is the initial value. I know that the slope is negative 3/4. And I usually just take that negative symbol out in front of the 3/4 and put it up in the numerator because negative 3 over positive 4 is the same thing as negative 3/4. So from there, I would rise negative 3, So 1, 2, 3. And I would run positive 4. 1, 2, 3, 4. And there is my next point. Oh, I went down 2, didn't I? I have my dot right here, and I didn't see it. There it is. It should be right there. Yeah, thank you. Just like that. And I'll take all my mess here and make it a little cleaner. And you could have instead thought of your slope as positive 3 over negative 4. So a run of 3 and a run of negative 4. Rise of positive 3, run of negative 4. Either way. But regardless, your line should look exactly like that. Okay? And then I also asked you to do number 6. We actually did problems like number 6 last week. So b is 5, or the initial value is 5. The slope is positive 3/4. So rise 3, run 4 would take us right there. We could also have a rise of negative 3 and a run of negative 4, but that would take us along the same line there. Okay? All right, go ahead and now do number 7, 8, 9, 10, and 11. Go ahead and do through number 11. And I will give you 2 minutes. All right, number 7. This means that x is always negative 3. So therefore, should be a vertical line going through x equals negative 3. Make sure that your graph looks like that. Number 8, another vertical line. X will always be negative 1. So that should be a vertical line going through x equals negative 1. Remember, number 7 and number 8 have a slope that is undefined. Number 9, you should have started at 0, 2. We have a negative slope, so we know this line better be going downhill from left to right. I think I'm going to go with a rise of positive 5, but a run of negative 3. You could have also gone with a rise of negative 5 and a run of positive 3. Regardless, that's what your graph should look like. Number 10, another one variable equation. We know at that point it's either going to be vertical or horizontal. Y is always positive 2 in this one, so that's a horizontal line going through y equals 2. Remember, the slope of that is 0. Number 11, we know this line better be going uphill from left to right because it has a positive slope. So we start at 0, negative 1, and we will rise 2 and run 5. And that's what your line should look like. So now we're going to work backwards. What if I give you a graph and I ask you to come up with the linear equation for that graph? Well, remember, there are really 2 things that make up a linear equation: a slope and a y-intercept. But those 2 things are easy. So if we take a look at our graph here, now we happen to have 2 perfect ordered pairs with dots on them. It makes it a little easier to see. So the slope from the graph is a rise of 3 and a run of 5. So the slope is 3/5. The y-intercept is right there at 0, negative 2, which means b is negative 2. So if we put those 2 things together for our linear equation, which all linear equations have a form in slope-intercept form of y equals mx plus b, put those 2 things together, the linear equation is y equals 3/5 x minus 2. That should seem easy. Okay? Could I get all of you to go ahead and try number 12? At number 12. What's the slope in number 12? Somebody tell me.
2.
2? All right, because that's what we need. We need the slope. We need the y-intercept. What's the b value of the y-intercept?
3.
All right, put those 2 things together. Easy. It is y equals 2x plus 3. All right, go ahead and turn the page. Go ahead and do 13 through 16. 13 through 16. All right, number 13, I can see that the slope is negative 4/3, rise of positive 4, run of negative 3. That means the slope is negative 4/3. I can also see there's a y-intercept of 0, 3, so the b value is 3. Putting those 2 things together, I conclude the linear equation is y equals negative 4/3 x plus 3. Number 14, I can see that the slope is 5/2, rise of 5, run of 2. And it is going uphill from left to right, so therefore the slope has to be positive. The y-intercept's at 0, negative 3, which means b is negative 3. So I conclude that the linear equation is y equals 5 halves x minus 3. Number 15. Now this time you'll actually have to find two perfect order pairs, but that's not that difficult. The line is going downhill from left to right. The slope is negative, so the slope is negative 1. The b value of the y-intercept is 4, so the linear equation should be y equals negative x plus 4. A lot of you had y equals negative 1x plus 4. You don't really need to write the 1 in there. You can, but you don't need to. Okay? And then number 16. Line is going uphill, therefore the slope better be positive. In fact, it happens to be positive 2. Y-intercept is at 0, 0, so b is 0. So the linear equation is y equals 2x. By the way, there's a special name for this kind of linear equation. Anybody remember what it is?
Oh,
It's proportional. It's proportional. Okay? Because it's a line that goes through the origin, and the equation looks like it's supposed to for proportional equations. All right, go ahead and do 17, 18, and 19. We're almost finished. 17, 18, and 19. All right, so we have a slope. I can see it's going to be negative. It happens to be negative 1/3, rise of 1, run of negative 3. B value of the y-intercept is negative 1, so the linear equation for number 17 is y equals 1/3 x minus 1. Now in number 18, we have a remember, all vertical or horizontal lines, that should be a trigger to you that this is an equation with only one variable. Now if you get stuck, look, you could do this. You could say, all right, well, I see negative 2, 0 there, and I see negative 2, 1 there, and I see negative 2, 2 there. Look, the x values are all negative 2 in those three ordered pairs. That might be a trigger that, oh yeah, this is going to be x equals negative 2. So remember, recall all linear graphs that are either vertical or horizontal only contain one variable, and it just depends on whether they're vertical or horizontal and where they're going through. Okay? So based on that, what would number 19 be? Tommy?
Y equals positive 3.
It's y equals positive 3. And you could go about this the same way if you're stuck. Look, we've got 0, 3. We've got 1, 3. We've got 2, 3. And you can see that all the y values are positive 3 there. Therefore, the equation has to be y equals positive 3. All right, now go ahead and do all four on number 20, and then we are finished. Caitlin, upper left-hand corner. Okay, I said upper left-hand corner. That thing's going uphill from left to right. There's no way the slope can be negative. Right? Okay. Nathaniel?
For number 20?
Yeah, the upper left-hand corner graph.
Yeah, I think the slope would be 2/3 x.
Well, that's not the slope.
Or I think I know the equation. It's
Okay, what is it?
y equals 2/3 x plus 5.
All right. And I can see that it would be 2/3 x plus 5. Y equals 2/3 x plus 5. All right, let's go to the upper right-hand corner. Upper right-hand corner. Tommy?
Y equals 3.
It is y equals 3. Good. How about the lower left-hand corner? Juan?
I've got x equals negative 5.
X equals negative 5. Very good. And how about the last one there? Clearly the slope is negative, so your slope better be negative, right? Dominic, what did you get for that one?
I got y equals negative 9 plus x equals 3.
Say that again?
So the very last one?
Yeah.
Y equals negative 9 plus x plus 3.
9/5.
That's what I got too.
Is that right? I mean, that might be right. That is right. Very good. y equals negative 9/5 x plus 3. Now, the reason why I wanted to end with that one is because in MyOpenMath, sometimes you might need to zoom in on the graph, and I know a lot of you have already figured that out. Zoom in to really get a careful look and inspection at the graph. Okay? All right, we are finished for today.